Hello everyone, in this video we're going over the unit circle, but before that I just have a couple remarks over something I saw in the last worksheet. So I think when I introduced like the right triangle and the trig functions, I had a triangle like this, and I said that something like this was the opposite side, something like this was the adjacent side, and then this of course is the hypotenuse. Um, and it seems like some of you may have taken this to be like the only possibility. However, these opposite adjacent um, decisions are made actually based on where the angle is, not always fixed. So like if we come to a triangle like this, the angle is now up here, and so the opposite side is all the way over here, right? And so it's always with relation to the angle. This is adjacent to the angle, meaning that this side, this leg here of the right triangle touches the angle. That's what adjacent means. And of course, this is still the hypotenuse here. So I have another problem on worksheet 15 at the end, just to make sure that you're getting this right, since it is important to be able to identify what's opposite and adjacent. So certainly look over your worksheet as I graded it, and also do the new problem on the worksheet 15. Okay, so coming down here to the unit circle, I have some of it filled in for you. The rest of it we'll kind of do together. And you can also find this printout on the course Moodle page. So here we go. You'll notice that I already have these little positive and negative things here already filled in. That's because we did this in the last section. The trig functions that are positive in quadrant 1, it's all of them, and none of them are negative. The trig functions that are positive in quadrant 2 is sine and cosecant. The negative ones are the other 4, cosine, secant, tangent, and cotangent, all functions of theta. Similarly, in quadrant 3, tangent and cotangent are positive, whereas the other 4, sine, cosecant, cosine, and secant are negative. And finally, cosine and secant are positive in quadrant 4, and the negative trig functions are the other 4, sine, cosecant, tangent, and cotangent. Okay, and then I also have the angles filled in for you, so you'll notice that as degrees, so starting at 0, which is the positive x-axis direction, that's angle 0, you get 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc., etc. Now, some of these are well-known angles, so if I start at angle 0 degrees, that's the same as angle 0 radians, so that's what this second line here is. And then going all the way around, if you go all the way around the circle, that's angle 2 pi. That's the same as 360 degrees. Going halfway around the circle is pi radians, which is 180 degrees. Now, the way that you would find the rest of these is you would take this degree measure and multiply by pi divided by 180, and that would be your angle in radians. So here you'd get 30 pi over 180, which reduces to pi over 6. And I'll just quickly fill in the rest of these. Okay, so pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, etc. Ending all the way over here with 11 pi over 6, which is almost all the way around. Now, here's how we're actually going to fill this in. On one of the pages that I've pointed to in the last video of the book, we're given some common trig values here. And so it turns out that this point right here is an ordered pair x comma y. And the x value is always the cosine of the angle. So the cosine of pi over 6 goes in the first coordinate here, and that's square root 3 over 2. And now the second coordinate is always the sine of that angle. So the sine of pi over 6 is 1/2. And you can verify that in the book on the page that I can't remember right now. And now here, let's do this one. So sine and cosine of pi over 4 are actually both the same. That's root 2 over 2. And here, for pi over 3, it turns out that it's going to be like pi over 6. It's just that they're both flipped. So here, this is 1/2, and this is square root of 3 over 2. So the cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. And then here, 0, 1 is all the way this point up here at the top. And now here's how we're going to fill in the rest. You'll notice that these 2 points are at the same height. So they both share square root of 3 over 2 as a y value. So the sine of 2 pi over 3 is square root of 3 over 2. But their x values, like they're perfectly mirrored from each other. So that's negative 1/2, right? So the cosine of 2 pi over 3 is negative 1/2. And now I'm going to go through and do the same with the rest of these, and I encourage you to do the same. Okay, and now coming here, if I look at, let's say, this point here and this point here, they are both at the same x value. Notice they're both at minus square root 3 over 2. But now their y values are flipped, so that's at minus 1/2. Similarly, this is at minus root 2 over 2, but also negative root 2 over 2. And this point here is at minus 1/2 minus square root 3 over 2. And now once again, to get these last three here, just play the same game. They're at the same height, so they're both at minus square root 3 over 2. But now the x value is flipped, so it's 1/2. All right, and that's the unit circle filled in. So I encourage you to either make your own or print this out from the course Moodle page and start to fill it in. Now what we're going to do is just come down here. This is also attached to the unit circle on the course Moodle page. You notice I have some values already filled in for you. This is essentially the first quadrant, the cosine, which is the first coordinate, and the sine, which is the second coordinate. And now to get the other four trig functions, well, you just follow how they're defined. So the tangent is defined as sine, which is 0, divided by cosine, which is 1. And that's why I get 0 over 1 equals 0 here. The secant is always 1 over the cosine value, so 1 over 1 is just 1. The cosecant is 1 over the, so 1 over 0, well, that's undefined, right? So that's where that comes from. And similarly with the cotangent, it's just the reciprocal of the tangent. Well, 1 over 0 is, again, undefined. And so going through for the rest of these, here, the tangent would be the sine value 1/2 divided by square root 3 over 2. The way you divide fractions is, of course, flip and multiply, and you get 1 over root 3. I'm actually happy with that, but if you prefer to rationalize, that's also root 3 over 3. Similarly, the secant, flip this upside down, right? Flip the cosine upside down, so you get 2 over root 3. Cosecant, flip the sine upside down, you get 2 over 1, which is just 2. And then flip tangent upside down to get cotangent, and you get root 3 over 1, which is just root 3. So I do this for the rest of the first quadrant. What I'll do is I'll just help you with, I guess, the first two columns here the rest of the way, and then I'll leave it for you to fill in the rest. But we saw that the first coordinate for the angle 2 pi over 3, well, that's the cosine. That's minus 1/2. And then we get a y value, which is the sine of root 3 over 2. Here, they were both root 2 over 2. It's just that one was positive and one was negative for 3 pi over 4. For angle 5 pi over 6, I get minus root 3 over 2 and 1/2. And then for angle pi, I get minus 1, 0. 7 pi over 6, both are going to be negative. And then at 3 pi over 2, cosine, the x value is 0, and the y value is negative 1. So the sine is negative 1. And then moving into quadrant 4, that's angle 5 pi over 3, I'm going to get a cosine value of 1/2 and a sine value of negative root 3 over 2, a cosine value of root 2 over 2 for 7 pi over 4, but negative root 2 over 2 for sine 7 pi over 4. And then root 3 over 2 here for cosine 11 pi over 6, but negative 1/2 for sine of 11 pi over 6. And finally, coming all the way back around the circle, the x value is, of course, 1, and the y value is 0. In the next video, we get into section 5.3, which will cover essentially the basic graphs of the trig functions and maybe something a little extra.